Everyone.
I'm Jim Baltzer. I'm a professor of biology at Wilfrid Laurier University, and having you join you here today. I'm going to be talking about wildfire and some threats to wildfire to landscape carbon. Now, of course, we know that in the system in boreal forest, wildfire is an essential part of the forest. It rejuvenates the forest, it reduces fuel on the landscape. It's really essential for getting heterogeneity at the landscape. The species in boreal forests are well adapted to fire, so it's a natural and important disturbance on the landscape. But the challenge is that with climate change, with climate warming, a drive, we're seeing changes in the way fire is impacting the land. And so these are just news headlines for 2014 and 2023, the two biggest fire years on record here in the territory. But what we're seeing is, changes in the way fire is acting on the land, larger areas burned, the potential for more severe fire, shorter fire return intervals, so less time between fires. Fires burning at times of the year that they haven't in the past, or very much in the past. So I'll just go through some of those very quickly in this bit of time that I have.
Here's just all the way.
Yeah. Okay. So first of all, area burn. This is something that we've heard lots about. In 2023, 15 million hectares of forested land burned in Canada. It was a record-breaking year for the territory. Here's 2014, here's 2023. And when we look at this graph, you could kind of, if you squint, you can kind of see certainly an increase in the frequency of these very large fire years. Large fire years mean lots of emissions. The larger the area you're burning, the more carbon emissions you're having leaving the landscape. And this is exemplified here. So this is the carbon emissions from the 2023 Canadian wildfires compared to other carbon emissions. And so this is really huge. When we have these big fire years, that the carbon implications are tremendous. Fire severity, it's a little bit less there what's happening, but there's lots of graphs here. We'll focus up here first. This is just a remotely sensed measure of fire severity, DNBR, difference normalized burn it. The DNBR is a difference normalized burn ratio. And dark red is more severe, yellow is less severe. This is through time. You can see there's not really any kind of pattern there from these remotely sensed measures of fire severity. This is the same thing plotted against the number of fires, the total area burned. Again, no real trends apparent there. So it's not as though when we're having these really huge fires like 2023, we're seeing a big signal of increased fire severity. There's landscape differences. This is the Big Hay River complex for 2023. These are the two complexes on either side of Yellowknife that led to evacuations. And of course, we see a lot lower severity burning here, higher severity burning here, so depending on where carbon stocks are in the landscape, this can have an impact. Another piece is that this measure doesn't necessarily capture those important soil carbon stocks that Laura mentioned. This is a picture, there's my hand. It's about 20 centimeters up from the soil surface. This is where the soil surface was before. So you can see there can be really tremendous combustion that is hard to capture from remote sensing. Shortage tool reburning. Again, this is from 2023, and all of these hillard areas are places where we had fires that were burning areas less than 60 years old. We tend not to have fires, or in the past, forests that are less than 30 years old have tended to be resistant to burning. They serve as wonderful natural fire breaks. But what we saw in 2023 is a lot of really short-old burning. The yellow patches, some of which are huge, they're less than 10 years old. These are forests that burned in 2014 and reburned, or before, or more recently, and reburned in 2023. These haven't had a chance to recover, and it's really sort of unusual burning conditions. Here's a picture of one of those where you can see the sort of shadows of trees from 2014 fire that combusted during the 2023 fires. So the impacts of shortage tool reburning, one of them is legacy carbon loss. So under a normal fire interval, you have a fire that burns through. It combusts some of that soil organic carbon. Maybe it combusts the trees in the forest, some or all. You lose a bunch of carbon, but not all of that new carbon that was laid down. Then you have a recovery period, a fire-free interval, during which time you recover soil carbon, you recover above ground biomass, and then the next fire gobbles away some of that, but that new carbon, much of it is left behind. And so you kind of have this layering effect where older carbon gets buried by newer carbon. This is a really important carbon sequestration mechanism in boreal forests. When fire return intervals are short, we found here in the Northwest Territories, what we see is combustion of all of that new carbon, and it bubbles away at the older carbon as well. So we see legacy carbon loss. That's your loss of this important carbon sink function. Another impact of short interval reburners is changes in the type of forests that recover. When we have one sort of short interval reburn, these are from Alaska. These pictures, here's a nice spruce forest, one short interval reburn. We see aspen recovery. We've seen a lot of that along Highway 3 as you're driving along, lots of aspen coming up under black spruce. 2 short interval reburns, it becomes very sparse, deciduous dominated, and then we basically get to a point where you have 3 short interval reburns that is sort of a shrubby landscape. And this really changes the amount of carbon that is stored on the landscape. These spruce forests store a ton of carbon in the soil. Shrubby areas, not as much. Another thing we heard a lot about in the news after 2023 was these overwintering or zombie fires, fires that are burning, starting one fire season, burning through the winter, smoldering in the soils and the roots and the boles of the trees, and then reigniting in the following season, or in some cases continuing to smolder through the following summer. We had the opportunity to get in to do some work in some of these overwintering fires to take a look at impacts on carbon stocks, impacts on tree regeneration, impacts on forest structure. All focuses in on these carbon measures. Kind of a good news story is that there in the Northwest Territories, there doesn't seem to be a huge impact from a carbon perspective. This is proportional combustion of the soil organic there. A little bit higher if it's on the dashed line. It means there's no difference between single season and overwintering fires. Depth of burn is not that different. Residual soil organic there, a little thinner in the overwintering fires, but not a huge impact. And a lot of this has to do with the fact that we are actually finding more of these overwintering fires in upland forests that are a bit drier. It was more burning in the woody biomass as opposed to what we were worried about was that they were overwintering predominantly at peatlands. And finally, I don't know what I'm doing time-wise. Amazing. Okay. Finally, kind of coming full circle to permafrost and these fire-permafrost interactions. So fire and ice don't play that well together. When you burn a landscape that has permafrost underlying, we burn through that organic layer that insulates the permafrost. We block in the surface, so a lot more of that sunlight and the energy from the sun warms the soil surface. You're removing the canopy, so you have less shading, so you change the energy balance of the system entirely. And we know that that follows a permafrost. This is a synthesis from the southern polar region, so we have tundra landscapes here and boreal landscapes here, from continuous to sporadic, discontinuous permafrost. And sort of, again, here's the zero line. If we're below the zero, it means that burned areas are flying more than unburned areas. And so, of course, we see this thaw response, and in continuous permafrost, this recovers. We see recovery of this active layer, so aggradation of permafrost following fire after time. But after fire, there is a period of time where you have this thickening of the active layer, and as Peter talked about, exposure of that lovely organic material to decomposition processes. And yeah, I guess I'm right on time. With that, you have to take any questions, but thank you for your